So they are throwing these conditions at us, and we have to graph a function that fulfills these conditions. There's more than one correct answer. What do you think I'm going to do? Yes, I want to summarize the whole thing. I have no idea where to start, what to do. Yes. Very good. So, I look at the first condition. Limit of f of x as x approaches 2 from either side. So, 2, let's say it's here. 2 from either side is negative infinity. Because I know what this means. As x approaches 2 from either side, most probably this is a vertical asymptote. The function may be defined there somehow, who knows, as a piecewise defined function, but yes.
Why did you make them touch?
They cannot touch because if the limit from the left and the right is negative infinity, this is definitely a vertical asymptote. And I can never make parentheses touch. I can make a bracket touch a parenthesis, but not two parentheses. And two brackets, that's not possible. Right? So this is done. I took care of this. I'm moving on. Limit of f of x as x approaches infinity is infinity. Next one. Limit of f of x as x approaches negative infinity is 0. Y equals 0, horizontal asymptote at negative infinity. Done. Limit of f of x as x approaches 0 from the right is infinity. Done. Limit of f of x as x approaches 0 from the left is negative infinity. Done. So here's what I know about this function. Definitely has a vertical asymptote at 0. And I will write it. I should write it. Not to forget. X equals 0 and 2 VAs. Vertical asymptote at 0. Vertical asymptote at 2. No horizontal asymptote at infinity. Horizontal asymptote at negative infinity, which is 0. And not defined, of course, at 0. It could have been defined as a piecewise defined function, but it's not. So, and not defined at 2. And now I'm ready to graph.
Can you
Yes. Yes.
why you know that they're vertical asymptotes?
Okay. Limit of the function as x approaches 2 from either side is negative infinity. This will not happen unless.
Right, because it's not going to 2.
Right. It will be. That's the. Yes, both sides negative infinity. So there must be a vertical asymptote. The limit of f of x as x approaches infinity is infinity. Is that okay? Okay. So limit of f of x as x approaches negative infinity is 0. Limit of f of x as x approaches 0 from the right is infinity. And limit of f of x as x approaches 0 from the left is negative infinity. So obviously this must be a vertical asymptote, this must be a vertical asymptote, and this is a horizontal asymptote at negative infinity. Better? Okay. So now when I graph this function, what do I have to graph first? Very good. And the horizontal one. So there is a horizontal one. There is no point in going all the way, but I have to in order to show horizontal. Then I have a vertical. This is an overkill, but I have to show that there's a vertical asymptote there. Then a 2. And now I'm ready to graph. From 0 to negative infinity. The first piece is done. In the middle, from positive infinity to negative infinity. From positive infinity on the right hand side of 0 to negative infinity on the left hand side of 2. And on the other side, from negative infinity approaching, when x approaches 2 from the right, to positive infinity. Any questions? Is this clear? All steps? All steps?
This again is you just making your own graphs.
Exactly. Yes, I could have done this if I wanted to. Yes. It says, sketch the graph of an example of a function f that satisfies all the given conditions. So this is done. This type of problem is done. This is what we just did a minute ago. And we already done so many different type of limits, and we can continue. If you have anything for me from before we start to that 7. If you have anything for me from the handout, if I could borrow the limit handout for a second. This one. Thank you. Yes. So I would like us to work on these two. So let's work individually for 3 minutes on these two, and please give me the answer on.
So on the graph, you're crossing the 0.
Anywhere I want. It doesn't matter. It has to come from positive infinity to negative infinity.
Okay, at some point.
Yeah, it's up to you where you want it to cross. I made it cross at 1.
So 13.
Yes. So for now, I would like us to look at those two problems at number 13. And let me know what you get. 3 minutes.
How about this one?
13, yes, those two at the bottom. I just want to see you work on those. And then we'll start to that 7. Oh yeah, I should copy them myself. So what was the limit?
First one was limit as x approaches infinity, 2x squared minus 5 over x squared minus 2.
And the other one, limit.
As x approaches infinity, parentheses,
Yes.
x minus the square root of x squared minus 4x.
Thank you very much. So let's work on these two and let me know if you need help. So the first one is 2x squared minus 5 over x squared minus 2. And you know the answer right away, but I'd like you to show the work. What is the answer? 2, indeed. Because both have the same degree. And the second one we can't conclude. We have to work hard on this. Not, I shouldn't say hard, but we have to work on the second one. Does anyone need help with the first one?
So
Yes.
this would just be how you write the answer, right?
Yes. So right, yes. So you factor out yes, 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 yes. But you have to get a number here. So you simplify x squared with x squared, and then you have to write 2 because this piece will go to 0 and this piece will go to 0. So what is possible is I will put 2 and I will simplify the x squared with x squared. Yes, I'll be right there. No, here we are only asked to find this limit. So you factored, you said that these two are going to 0, let's put the equal symbol here. That's okay. And then we have, yes, perfect. Now we are working on this. Yes, because 5 divided by infinity is 0 and 2 divided by infinity is 0, so we find that limit is 2, and I would write y equals 2 horizontal aspect. Anyone else?
I just want to make sure that
Yes.
it's a
Yes, because you have to check first. You have infinity minus infinity, so you have no choice but to rationalize the numerator. Very good. How are we doing? So what did we get? So the limit operator disappeared. I can't have that. So it looks fine, but the limit operator is not there, so you cannot say that this equals this without the limit operator in front. So we cannot drop the limit operator. Please be very careful, please. Any questions?
just had a minor mistake.
Okay. So please do not drop the limit operator till the very last step. We cannot drop the limit operator. Now, assuming we finish this chapter, I just have a few things to tell you from 2.7 to 8. All next Monday, we are going to work on problems in preparation for the test. Okay?
So it's
So
going to be nice.
yes, yes. Is that okay? Yes, I'm going to make it shorter. I'm going to try to make it not more than an hour. Okay, an hour and a half at the most. Okay. Do we need more time for this one? Okay. Okay.
2 minutes.
Okay.
This one, yes.
Ready? Yes. Perfect. Perfect. Yes. 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 Ready? I have to plug in infinity, and I do get infinity minus infinity. How do we call this? Indeterminate case. One of the three that we had encountered so far. 0 over 0, infinity over infinity, infinity minus infinity. We did not encounter the other ones, the other four yet. So in this case, my only hope is x plus the square root of x squared minus 4x over x plus the square root of x squared minus 4x. Now, I don't remember. Yeah, I think Paul did that. So I was still thinking of whether at the first look I missed something. Okay, so this is basically x squared minus x squared plus 4x over x plus the square root of x squared 1 minus 4 over x. So far, so good? Are you with me, everyone? Okay, these two go away. Luckily, x approaches infinity, so the square root of x squared will be simple plain x. So this is limit as x approaches infinity from 4x and x plus x, the square root of 1 minus 4x. And then I will have to factor in the denominator. 4x over x, 1 plus the square root of 1 minus 4 over x. These two go away. The numerator only now, please notice, please, just hold your thought, don't forget what you want to say. Please notice that I did not drop the limit operator. I can't give full credit if you write that this equals 4 or something. I can't. The limit of this equals a number. So please. So the numerator goes to 2, the denominator goes, the numerator to 4, the denominator to 2. Yes, please.
So I lost you on
so I factor out x squared, and I have 1 minus 4 over x. Then I have the square root of x squared, which is x. Because x approaches infinity, I cannot change this to negative. It has to be positive. And then I factor out x to simplify it, and I got 4 at the top and 2 at the bottom. Notice that the limit operator disappeared right at the last stage when x goes away. Yes, please, Joey? Say it again.
Would it be minus 4x at the top? Yeah.
Very good. Let's take a look. The first term squared minus the second term squared, and I have x squared minus 4x. And when I distribute negative 1, I have negative x squared but plus 4x. Right? Because I have the first term squared minus the second term squared. And I put parentheses. And then I distribute x squared plus 4x. Is that okay?
Say it again.
This is A, this is B, this is A, this is B. A minus B times A plus B is A squared minus B squared. So minus x squared minus negative 4x. Is that okay?
Yes.
You wanted to say something?
Yes, that's the very end. Can you explain how you got 2 in the denominator?
Yes. This approaches 0. This is 1 plus the square root of 1, which is 2. 1 plus 1 is 2. Is that okay, everyone? Nico?
Yeah. Well, up the square root of x squared.
Yes, the square root of x squared is x because x approaches infinity. We would have been negative x if x approached negative infinity.
Yeah. But then you factor.
And then I factor out because this is multiplied. So x times 1 is this. X times the square root is this.
Oh, okay.
So from these two terms, I have to factor out x. X times 1 is this. X times the square root is this. Does it make sense? Yes?
Yeah.
So I can,
Just how the terms are written. Yeah.
so if you want, I can go back to the previous example, and you'll see we did the exact same thing.
Yeah, I was.
It's okay. It's okay. Right here. Maybe this is better if we go back for a second. So x plus x times this. I factor out x. X times 1 is this. And x times the square root is x times the square root. Is that okay?
Would it help if you wrote the 1 on the outside?
Oh, yeah. Okay.
I think that's the only thing. Yeah. It's implied, but
Yeah, that makes sense.
Is that better?
Yeah.
Is this clear? So now I conclude that y equals 2 is a horizontal asymptote at infinity only. Is that understood? Okay, so I would like now, I know I only have half an hour, we will do whatever we can. So I would like to continue with 2.7, derivatives. Say it again.
so now we come to derivatives.
Right, but it's nothing new. You will see in a moment. Derivatives and rates of change. And also 2.8, which is the derivative function. Yes, they go together. But we'll start, of course, we'll start with the 2.7. Okay, so let's go back to the first day of classes, basically. So this is our function f of x. Of course, this is our p, point P. And I would like to determine, find the slope of the tangent at P. What did we do? Can anyone refresh our memory? Yes, we looked at the difference quotient. Can anyone remind us what the difference quotient was all about? This time we have to remember it in this class. We need to know it.
F of x minus f of x.
Good. So this was basically the slope of a secant line, right? Between P and Q. So now I want you to tell me, in view of what we've studied in this chapter, how do I write the slope of the tangent line at P? I need to put something in there that we've been using for a long time. Of course, it's the limit. The limit as age approaches, of course, from f of x plus h minus f of x divided by h. This is what we wrote, but a long time ago, but we did not write it with a limit operator. I said when h approaches 0, the slope of the secant line approaches the slope of the tangent line because the secant line approaches the tangent line, blah, blah, blah. But now, finally, I can put the limit in front of this. Yes. So this is the slope of the tangent line to the graph of function f of x at P. This is it. Now, if I have, so this is one way, and the notation for this in section 2.8 will be f prime of x. So let's write what f prime of x represents. F prime of x is the slope of the tangent line to the graph of f of x at any point where the function is, I'm going to use a word that I have to explain. So f prime of x is the slope of the tangent line to the graph of f of x at any point where the function is differentiable. Now f prime of x is a function called the derivative. Derivative function of f of x. So this is not only the slope of the tangent line to the graph at P, but also the rate of change of the function at P. It's, I'm going to write on three. It's also the instantaneous rate of change, the instantaneous velocity of function f of x if the function is a distance function. So f prime of x, in summary, derivative gives the slope of the tangent line at any point. Also gives the instantaneous velocity at any point if the function is the distance. F of x, distance. It's all of the above. The slope of the tangent line, the instantaneous velocity, as well as the derivative at any point where the function is differentiable. So when we say the function is differentiable, we mean where the function has a tangent and where the tangent has a slope. There are three situations in which a function is not differentiable. So when is a function not differentiable? Not differentiable. In three situations. Differentiable. Not differentiable. Here is a situation in which the function is not differentiable, and you'll tell me why. So let's say this is a. I claim that this function is not differentiable at a. Because it's not continuous. If a function is not continuous, it cannot have a derivative at that point. It's not differentiable at that point because it's discontinuous. Discontinuous. If a function is not continuous, it cannot be differentiable. Here is another situation. Also similar to this situation. At this point, which is a, at this point, which is a, this function, these functions are not differentiable because they have either a cusp or a corner. Cusp and or corner. Here's why. Let me explain why. What is the tangent here? I don't know. There is a tangent on this side, and there is a tangent on this side. The tangent on this side is positive. The tangent on this side is negative. Which one is the tangent? So at the corner, the function at a is not differentiable. Same thing here. Which one is the tangent? I don't know. This one is negative. This one is positive. I have no idea. So cusp and corner, for a cusp or a corner, the function is not differentiable. It will not have a derivative. Why? Because the derivative on the left-hand side of a is negative, and the derivative on the right-hand side of a is negative. So the derivative has a gap. It's a function with a jump. So on one side is negative, on the other side is positive. So the derivative will not exist there. Okay, so here's the last one. I'm going to graph x cubed. I'm sorry, I meant the cubic of x. So what am I doing? It's not x cubed. It's the cubic of x. I'm sorry, the cubic of x. X cubed is always differentiable because it's a polynomial function. It has no cusp, no corner, nothing. So here it is. This function is differentiable everywhere except at 0 because it has a vertical tangent. And in case you're thinking, how is she coming up with these numbers? I want to look at the graph. And I'm just trying to find a graph that I can work with. In your book, maybe, or I can make one up. It doesn't matter. Okay. Yes, from your book. I want you to choose. So it says trace or copy the graph of the given function, assume that the x-axis, then use the method blah 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 to sketch the graph of f prime. So choose any problem from 4 through 11.
What's the page?
Page 162. Page 162, because I would like to talk about or show you how to determine a sketch or how to come up with a sketch of the derivative. We want to look at 5? Perfect. So I'm going to copy 5 on page 162. So here's the graph on 5. So make sure you have enough room under the graph because we are going to graph both, one under the other. This will be the function and this will be its derivative. So I'm copying the graph to the best of my knowledge or ability. So I think it's something like this. Yes? Do you see it something like this? Yes?
Yes.
Okay. Perfect. So this is the given function. We are trying to find or sketch a rough graph, an estimate of the derivative. What is the derivative? What it will give us? It will give us the slope of the tangent line to the graph of this, anywhere where the function is differentiable. Right. Okay. So I'm going to come up with some points. Obviously, I'm hoping that my graph is as exact as possible of the copy of the graph in the book. So obviously, I will say that this right here, the tangent is 0. I would say that here is big positive, but here is smaller positive. And this is smaller positive, and this is 0. Difficult to estimate, especially from my graph. I'm going to imagine that I draw a right triangle. I'm going to say that this appears to be 2 and this appears to be 1. So 2 over 1 for the tangent of the slope, I'm going to say is 2. So at this point, for this x value, I will graph 2. Then for this point, let's say this is at negative 1.5. I'm going to say, I think that this is kind of 1 over 1. So then at this point, I'm going to plot 1. You can say, how do you come up with this? Very difficult, right? So I'm just saying that this triangle has a height of 1 and a run of 1. This one is steeper, so I said, okay, it has a rise of 2 and a run of 1. Very approximate, right? Rough approximation. Here's a little bit more difficult to come up with. I already have a 1, so, but here, obviously, it's 0. So the function that I'm going to start graphing will give us the slope of the graph, the slope of the tangent line to the graph of f at any point. So if you want at this point, the slope is 2. For this x value, the slope is 1. For this x value, the slope is 0. Now, obviously, it starts a negative slope. So this one is a negative slope. This one is a negative slope. This one is a negative slope. This one is closer and closer to what?
0.
Right. So it starts on this side, it starts negative. At some point in time is the huge possible negative. So I'm going to say that this is not that steep. This is steeper. I mean, this is maybe -1, and this is a little bit less, and this is closer to 0 and closer to 0 and closer to 0, right? So it goes to negative values and eventually will come back to 0. And this is a rough estimate of the graph of f prime. So coming back to what f prime is, again, is the derivative of function f of x, which gives the slope of the tangent line to the graph of f of x at any point where the function is differentiable. Now I'm going to ask you to look at these graphs one more time. And let's say for 8, is this function differentiable everywhere? Will you be able to draw a continuous derivative? No, because at this point, as you see on this side is negative, on this side is positive. So it will have the derivative will have a gap, a jump. Okay. Now, maybe we should look at one more. So exactly the same thing. This is a vertical tangent at 0. So the derivative does not exist there. So maybe we should also look at problem 10. Let's do one more so we can have a better idea.
So you just put
Yes?
B and E for the ones that you can't?
No, at that particular point.
Okay.
At that point. You want to work on one of those? Yeah.
Yeah.
Yes, that's fine. That's fine. Let's copy 8. And so this will be f and this will be f prime. You understand why the graphs have to be one under the other, so that I can have this, so I can analyze the same x value. And okay, so I think the graph looks something like this, right?
Yep.
Is it?
Yeah, it's pretty much exactly.
Okay, good. So now we want to sketch a rough estimate of f prime. Okay, so I draw some tangents. I draw some tangents. And I try to estimate. Of course, especially on my scratch paper here, it's very difficult. I'm going to come up with some numbers. Okay, so let's say definitely this is not as steep as this one is, right? So I'm sorry, this is steep in the negative sense. This is less steep in the negative sense. This is less steep in the negative sense, and this is less steep in the negative sense. Would you agree?
Yes.
So this is the biggest negative. So I'm going to try to come up with an estimate. Again, here I'm going to come up with an estimate. Here I'm going to try to come up with an estimate. Here I'm going to try to come up with an estimate. Very difficult. But I will have to present those triangles and look at rise over run. So since I know that this is the steepest, I'm going to say, I don't know, 3/1, but negative. This is negative, but let's say a little bit smaller. So for this value of x, it's not -3. I'm going to say it's -2. And here for this value, I'm going to say it's -1. And this is closer to 0. So this is my graph. On the other side, all of them are positive, and this is the biggest positive. I'm going to say it's positive 3 because it looks like it's symmetric. And then for this one is a little bit smaller, and for this one is a little bit smaller, and for this one it gets closer and closer to 0. So this is the graph of the derivative. And as you see, the derivative is undefined. Yes, yes, it's undefined in both.
So both of them are
Yes. Yes. Because the function is continuous there, but it's not differentiable, which means the derivative does not exist. Let me explain one more time. Let's take a look here. When the derivative, it's a very good question. Thank you for saying that. So when this exists, only when the limit from the left of 0 of this and the limit from the right of 0 of this are the same. But the limit from the left of 0 is -3. And the limit from the right of 0 is +3. Therefore, this function does not exist. This limit, which is the function, does not exist at the particular point that we are looking at. So both limits left and right have to exist and have to be the same number for the derivative to exist. Because as you see, the derivative is what? Is a limit. Is a limit of a ratio. Does this make any sense? Okay. So now I would like to, I know I only have a couple of minutes. I would like you to choose a problem, and I'll stop after this, between 21 and 33 on page 163. And if you could choose anything that is not on the checklist.
Can I ask a real quick question?
Yes. Yes.
What is this applicable to? Why would this be?
Right. Yes. Here's yes. We're gonna get to that. Here's, for example, if you want to determine, if you have the distance function and you want to determine the velocity. Let's suppose you also want to determine the distance covered by a particle going back and forth. That's going to be the inverse of the derivative. Yes. We're going to get to that in chapter 5. Now, no, it's a very good question. So we're going to look at examples like, let me give you a specific example that you're asking, because that's a very good question. Thank you. For example, perfect question, because it makes sense. Absolute sense. I just didn't get the chance to show you. For example, the number of bacteria after T hours in a controlled lab experiment is denoted by N, which is function of T. So the number of bacteria in a controlled lab experiment. What is the meaning of the derivative f prime of 5? It's an excellent question. I was expecting that. So what does f prime of 5 mean? The rate of change of the number of bacteria immediately after whatever, minutes, hours, what was it? T hours. So if I have this function and I determine f prime of 5, first I have to determine f prime. And then I plug in 5. And then I would know how fast is the bacteria, the number of bacteria changing right after 5 hours. Next question. What are its units? Remember, it's a rate of change. I have to have a measurement unit coming from the top and a measurement unit coming from the bottom. So the rate of change, let's say f prime of 5 is 100. What does 100 mean? Number of per hour. That's it. Suppose that there is an unlimited amount of space and nutrients for the bacteria. Which do you think is larger? F prime of 5 or F prime of 10? Careful. So, we have this room, it's empty. And 10 people come in. I'm sorry, 5 people come in and then 6 people come in, and then 10 people come in. And this is not unlimited. Not unlimited. So the more people we fit in, the slower the rate becomes. Because this is not unlimited, right? So the first 5 come in, and it's empty. The next 5 come in, it's still kind of empty. But as far as we continue doing that, 20, 25, 30, 50, 60, it's going to slow down. The rate of change is not going to be fast. But now imagine that there is unlimited space in this room. Which of the two, f prime of 5 or f prime of 10, will be faster? Yes, because there is no unlimited. But if it is limited, f prime of 5 is faster. Everything else will slow down.
So when you limit a derivative, you change the pace.
Yes. So when it's unlimited, the more people that come, the faster the rate.
It was unlimited, wouldn't it be the same?
No. If it's unlimited, it will grow forever, fast. But if it's limited, the more people come in, the slower it is to fit them in. So f prime of 5 will be a higher rate than f prime of 10. But if it's unlimited, f prime of 10 will be higher than f prime of 5. Because it's growing. We're talking about bacteria. My example is not exactly the same with bacteria. Bacteria will grow faster when there are more and more and more and more because they multiply faster. So the rate of change will be higher. But if we have limited space, then f prime of 5 will be higher. Because then they can't grow anymore. There is not enough room for them to grow fast. So they will grow much slower. So which do you think is larger? So f prime of 5 or f prime of 10 for unlimited? If the supply of nutrients is limited, would that affect your conclusion? Yes. So f prime of 10 will be much slower than f prime of 5. Okay, I have a few more minutes. 8:40. Okay, which one?
29.
So what am I doing? Oh, you picked 29. Oh, yes. Okay, thank you for picking. Yes. So let's take a look at 29. Where was it? Okay. So g is a function, g of t, and we have 1 minus 2t divided by 3 plus t. Thank you for asking the question, because I always want to relate what we're doing to examples, so you see, what is the use of all this. So we are asked to find f prime of t. What do I have to write?
Would this technically be g prime of t?
I'm sorry.
That's not right.
I don't like g. So we have to find g prime of t. Thank you. My fault. I'm sorry.
I'll take what I can get.
So g prime of t is
The
1 minus 2 t
3
plus
plus t over 1 is 2, negative 2 over 1.
Do you plug it into the difference quotient?
2 over
We
2
can't
over
see.
5.
keep going.
The limit.
Of course. The derivative is a limit. The derivative is a limit of what? That's it. So let's start.
So say that again. The derivative is the limit of
The derivative is the limit of
the difference quotient.
the difference quotient. The derivative is the limit of the difference quotient. We established that. How did we establish? Oh, 3 weeks ago, right? When we said that the slope of the tangent line is obtained when h approaches 0 from the slope of the secant line. Right? So, yes, I'm ready. But h good from
1 minus
2t plus h.
minus, yes, if you want to write it like that, that's fine too. Okay, divided by,
3 plus t plus h.
very good, minus, over,
3 plus 1.
3 plus t over? Good. You have 2 minutes.
Can you move it over a little bit?
We have been doing this from day one, right? The only thing that we have not used from day one was this. This is the only thing we have not used from day one. But we determined the difference quotient for all sorts of different functions. That's the only thing we did, right, from the very beginning. Now, the only thing I'm asking you to do is just add the limit operator. And that's the end of it. Is it okay? Any questions? So this is the limit of the difference quotient. You have to distribute to, you have to find the least common denominator, you have to find the adjustments for the top, simplify, and give me the answer. Does everything come together now? You understand the connection between the difference quotient and the derivative and the limit? Just have a question. So you have to distribute. You have to distribute, and so this is 3t plus 3 plus t.
Yes.
So that will be t. So the least common denominator is the product of these two, and then this has to be multiplied. But you have to rewrite it first without parentheses. It would be easier if you rewrite it without parentheses at the top. Anyone needs help? Was this clear? Did we understand how why the limit, the derivative is the limit of the difference quotient? We understand that? Yes? I know it's tiring to do math for 2 hours in a row. I know that. Oh, sorry about that. The least common denominator. Good. Adjustments for the top of the first one. Very good. And for the top of the second one. Can anyone dictate the top of this new limit?
3 minus 6t plus 6h plus t.
Minus 6h. Careful. Because I have a minus in front. Okay. So 3 minus 6t minus 6h plus t minus 2t squared minus 2th minus 3 minus t minus h, but plus plus 6t plus 2t squared plus 2th. So here's my question. Every time we determine a difference quotient, two things have to happen. What are they?
H has to cancel, or no?
That's the second one.
Yeah.
That's the second one. What is the first one? All terms from the top that do not have h must go away. Maybe some of the terms with h go away, but that's a plus. So that's how I know if I make a mistake. So the positive 3 with the negative 3. The negative 6t with the positive 6t. The negative 2t squared with the positive 2t squared. 2th with a negative 2th. The positive t with a negative t. What is left at the top? So negative 7h divided by h. So negative 7h over h, because I flipped it already, 3 plus t, 3 plus t plus h. I simplify. Now, only now, I drop the limit operator. The limit from the top is negative 7. This I cannot touch because it's 3 plus t, not h. And this, h goes away. So negative 7 at the top and the bottom, everything squared. Negative 7 over t plus 3. Forgive me, I meant to write 3 plus t, but it doesn't matter.
Oh, I see it.
Is this a function? Yes. What does it represent? The derivative of function g of t at any point where g of t is differentiable.
Is that what we need to write?
Yes, I would write it at least once to remember what it means. Yes, I would.